Assalamualaikum everyone. In this episode, we will analyze a problem that involves static and kinetic friction. How do we determine the force of friction if a horizontal force acts on a crate given the coefficients of static and kinetic friction and the mass of the crate? To find it out, just hang on, watch and learn. The question is, a 20.0 kilogram crate is at rest on the floor. The coefficient of static and kinetic friction, μ of S and μ of K, between the crate and the floor are 0.70 and 0.60 respectively. A horizontal force, capital P, is applied on the crate. Question letter A. Find the force of friction if, small letter A, if the force P is equal to 20 point Newton. Case letter B, if the force P is equal to 30 point Newton. Case letter C, if the force P equals 120 point Newton. Case letter D, if the force P is equal to 140 point Newton. And case letter E, if the force P is equal to 180 point Newton. And question letter B, what is the acceleration of the crate, if there is any, once it has been set into motion? Let the magnitude of acceleration due to gravity be equal to 9.80 meters per second squared. We first identify the forces acting on the crate whose mass m is equal to 20.0 kilogram. Its corresponding weight, W, is 196 newtons. Now this weight, small w, is balanced by the upward force of the horizontal surface, which is the floor, okay, denoted here by capital F sub n, also known as the normal force. All right. So this weight of the crate equal to 196 newtons, okay, is just equal to the magnitude of the normal force F sub n. We are also given the coefficient of static friction equal to 0.70 and the coefficient of kinetic friction equal to 0.60. All right. So, as shown in the diagram, the horizontal applied force is capital P and it's directed to the right. Hence, the opposing frictional force, small f, is opposite to the applied force P. And our target variable, all right, for question letter E, is to find this force of friction, all right, given the following cases or conditions, like in letter A, what is the force of friction if the applied force P is equal to 20 Newton? In case letter B, what is the force of friction if the applied force P is equal to 30 Newton? Okay. Case letter C, what is the force of friction if the force capital P is equal to 120 Newton? And for case letter D, what is the force of friction if the applied force P is equal to 140 Newton? And lastly, what is the force of friction if the applied force P is equal to 180 Newton? So to answer question letter A, we first calculate for the magnitude of the maximum static friction, denoted here by F sub S max. Alright? And its formula is just to multiply the coefficient of static friction, mu sub S, by the normal force, capital F sub N. Alright? So substituting, we have 0.70 as the value of mu sub S and 196 newtons for the normal force F sub N. Alright? So doing our math, we will get the maximum static friction equal to 140 newtons, okay, in two significant figures. Alright? So we can now proceed in answering questions letter A to letter E. But let's start with question letter A. What is the force of friction on the crate if the horizontal applied force, capital P, is equal to 20 Newton? Right? Alright. Our answer is the force of friction, which is in this case static friction, is just equal to the negative of the applied force P. Since the applied force P is only 20 Newton, therefore the force of friction or static friction is equal to negative 20 Newton. Alright? Why is this so? This is because the crate remains stationary, okay, as the applied force P is still less than the maximum static friction. Alright? 140 newtons, which is the maximum static friction, alright, is much greater compared to the applied force in case letter A, which is only 20 Newton. Alright? Newton's first law, or the law of static equilibrium, requires the net force, alright, or the resultant force acting on the body, alright, if the body is at rest, the net force must be equal to 0. Alright? That is why we are able to say that if the applied force P, okay, is way below the maximum static friction, then okay, we are only talking about a situation where the force of friction, okay, is simply equal but opposite to the applied force. Alright? So that the summation of the horizontal forces must be equal to 0. Okay, now let's move on to case letter B. All right, this time the applied force capital P is equal to 30 point Newton. All right, still, the applied force P is way below the maximum static friction. So, our answer is that the force of friction, which is still static, okay, is just equal to negative 30 point Newton. All right. The same explanation as mentioned in letter A. That is, the F net acting on the crate remains 0. All right. The applied force of 30 newtons is just balanced by the static friction, and so therefore the value of the static friction is just equal to 30 newtons but directed to the left or opposite to the applied force. Okay, moving on to case letter C, where the applied force P is increased to 120 point Newton. All right, still the applied force P is below the maximum static friction. All right, so just like in the preceding cases, the crate remains at rest, but there is an applied force of 120 newtons. So this applied force is just balanced by the static friction equal to 120 point Newton, but directed also to the left. Right? Now for case letter D, the force applied capital P is now exactly equal to the maximum static friction, which is 140 point Newton. All right? And the question is, what is the force of friction acting on the crate if the applied force P is exactly equal to 140 point Newton, which happens to be the maximum static friction. All right? So, you will notice that the two forces acting on the crate have equal magnitude but opposite in direction. And so therefore, the net force acting on the crate is still equal to 0. All right? The crate remains at rest. And so therefore, it is in static equilibrium. So our answer to question letter D, all right, the force of friction is just equal to the applied force P, 140 point Newton, but still directed opposite, meaning to the left. All right? The applied force has just balanced the maximum static friction. And for case letter E, if the applied force capital P is equal to 180 point Newton, all right, which is now greater than the maximum static friction, all right, the crate will now start to move. All right, because the applied force is now greater than the maximum static friction. All right, and in that situation, uh, the question of how much is the friction force acting on the crate? Okay, if that amount of applied force is exerted on the crate. All right, our answer is the force of friction will now be equal to what we call the kinetic friction. All right, the kinetic friction is the opposing friction, okay, that the moving body will experience. That's why it's called kinetic friction, because now the crate is in motion. All right, and why is it equal to 120 newtons? Because if you're going to calculate for the kinetic friction F sub k, whose formula is equal to the product of the coefficient of kinetic friction and the normal force capital F sub n, all right? So when we multiply 0.60 and 196 newtons, we will get the product equal to 120 newtons in two significant figures, all right? But in terms of direction, of course, the direction of the kinetic friction is opposite to the direction of the applied force. Since the applied force is to the right, therefore the kinetic friction is directed to the left. All right? So, we are done answering questions letter A to letter A to letter E. All right? So, moving on to our second main question, which is finding the acceleration of the crate. All right, if there is any. All right, there are three possible scenarios that may happen. All right, the first scenario is if the force capital P is reduced to exactly equal to the kinetic friction. That is, if the applied force P, okay, is equal to 120 newtons. All right, that is the first scenario. So what will happen? We say that um, in such situation where the applied force, okay, is just equal to the kinetic friction, then the crate, okay, will still be in equilibrium, but it's now considered dynamic equilibrium because it is in motion. All right. So the first law still holds, meaning the sum of the horizontal forces must still be equal to zero. All right. In short, the net force acting on the crate is still equal to zero. And so therefore, the applied force capital P equal to 120 newtons is exactly balanced by the kinetic friction negative 120 newtons. All right. So that is the first scenario. All right. If Fk and the applied force P are numerically equal, then the crate moves at constant velocity in accordance with Newton's first law of motion. What is the second scenario? All right. So, if the applied force capital P, right, is uh, less than the kinetic friction, say for example, the magnitude of the applied force P equals 100 point Newton. All right, what will happen to the crate? All right, so Um, in such situation where the applied force is less than the kinetic friction, then we say that the body or the crate is no longer in dynamic equilibrium. All right? Once it has started to move, because the force of or the maximum static friction has been overcome, all right, in our preceding situation, that is. But while the crate is starting to move and the applied force is reduced to a value that is less than the available amount of kinetic friction, in our example, the kinetic friction is 120 newtons, but the applied force is reduced, say for example, to 100 point newton. All right, so they are no longer balanced. All right, so while the crate continues to move to the right, but it is now what we call slowing down. All right, slowing down also means that the crate will start to decelerate. Okay, negative acceleration, that is, until, all right, it comes to a stop. That is scenario number 2. The third scenario is if we assume the horizontal applied force P is equal to 180 newtons and it is held constant after the crate has been set to move, and supposing this is the scenario that we are going to choose, all right, where the available kinetic friction, of course, is still equal to 120 newtons in the opposite direction. But with an applied force, capital P, equal to 100 point, 180 point newton, then obviously you'll notice that there will be a difference. All right, there will be a difference in the two opposing forces, suggesting that there is a net force, that is directed in the same direction as the applied force. All right, so we can imagine that the block or the crate, okay, will be moving to the right with an increasing velocity. That is, it's going to accelerate, right? So that is what's going to happen if there is a net force, okay, that acts on the body in the direction to the right. The acceleration will also be directed to the right. All right, and that is what we're going to calculate in just a short while. We will find out what the acceleration of the crate will be if the amount of applied force P is maintained at 180 point newton and the opposing friction is kinetic friction equal to 120 newtons. All right, so continuing with our calculation for the acceleration, the crate, where we assume that the applied force, capital P, is maintained at 180 Newton. All right. So assuming that that applied force, capital P, is held constant. Okay. The net force that will be exerted on the crate, okay, will just be equal to the applied force, capital P, minus the kinetic friction, F sub k, which is equated to the product of the mass of the crate and its acceleration A. All right. So when we isolate uh, the target variable, which is the acceleration A, we simply get the net force 180 point Newton minus 120 newtons and divide it by the mass of the crate, which is given as 20.0 kilogram. All right. So doing our math, finally, we will get the value of the acceleration equal to 3.0 meters per second squared in two significant figures. So I think we are done. All right. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.